Last concept here. So we're still talking percent yield, added another wrinkle to this now. So you've seen this reaction before, so I didn't want anything to be a surprise. So you have 4 grams of CH4, methane, and 18 grams of oxygen. How much carbon dioxide and water can you make? So let's get back to that in a second. And if you made 12.5 grams of carbon dioxide, is this possible? So it's implying percent yield. It doesn't come out and say, what's your yield? But as soon as it says, hey, can you do this? You've got to analyze whether or not that's possible, and then why or why not. So again, one of the wrinkles that comes in here is if they say, if you made this, it's implying percent yield. You've got to compare to what you've got to compare what you made to what you theoretically could have made. So even if I don't come out and say, this is a percent yield problem, when you read this, you've got to analyze and say, hey, this is a percent yield problem. Up on the first line, oh, there's 2 reactants, and I didn't say you have enough of one or the other so you can just start calculating moles. It's implied now that it's a limiting reagent problem. So before you can do percent yield, you've got to figure out which one of these 2 is holding me back, find out which one's holding you back, calculate how much you could make of both water and carbon dioxide, and then figure out your percent yield. So let's do it. Okay. So first thing when you're doing limiting reagent is you got to get moles. So 4 grams of methane over 16 grams per mole, well, that's 0.25 moles. 18 grams of oxygen over 32 grams per mole, and I gotta look at my notes here now, is 0.5625 moles. And I know you can round here, but let's just leave this for a second. Okay, it's a 1 to 2 reaction. I always like working with the one that's my number 1. So you need 1 mole of methane to react with 2 moles of oxygen. You need 2 moles of methane to react with 4 moles of oxygen. Well, let's double this, and that will tell me which one's my limiting reagent. If I double this number, and the number that I get here is more than my oxygen, then oxygen's my limiting reagent. If I double this number, and the number that I get is less than my amount for oxygen, this is my limiting reagent. Well, this should be pretty obvious. 0.25 times 2 is 0.5. Let me compare. Oh, this number here is less than the actual amount of moles of oxygen I have. Here's my limiting reactant. I'm going to have oxygen left over, and then, oh, I can base my 1s and 2s on the other side over here. So let's fill out the rice table based off of 0.25. R, I, C, E, good. We go down. So 0.25, 0.5625, and that's only going to be important because it's left over. We don't have those to start. Change line, well, my methane's going to be gone. 0.25 times 2 is going to be a minus 0.50. Oh, 1 to 1 on methane to carbon dioxide, 0.25. 1 to 2 on my water, 0.50. So when I'm done, no methane. I didn't ask you to calculate this. You could subtract. We're just going to say excess. Makes our life easy. 0.25 moles of carbon dioxide and 0.5 moles of water. So in the question, I ask how much CO2 is possible and how much water is possible. So carbon dioxide, you made 0.25 moles, it weighs 44 grams per mole. Well, you made 11 grams of CO2, possibly. Your water, well, you made a half a mole, weighs 18 grams per mole. 18 times 0.5, 9 grams of water. So, just like all the limiting reagent stuff that we've done so far, nothing new about this. Now let's take this into percent yield. So, we could have made, at most, 11 grams of carbon dioxide. Let's flip that into the percent yield stuff. I need longer arms, guys, I'm sorry. So, same thing with we've always been doing percent yield. It's what you actually did make over what was possible. This is what you did in the lab. This is your stoic calculation times 100. Well, way back at the beginning, I said, hey, you made 12.5 grams of carbon dioxide. You could have made 11 grams. Multiply it by 100. When you do that, you get 114%. So you stop and you analyze and you say, wait a minute, is this possible? No, it's not. You went over 100% yield. You violated law of conservation of mass. You cannot make more than what's theoretically possible. When you do percent yield and you go over 100%, it doesn't tell you where your error is. It could have been that you did a math error and you need to go back and check your stoichiometry work. Maybe you're not off and you just need to check your numbers. If your numbers are right, then it's a lab error. What did you do? Did you measure things wrong? Did you not separate your products from your reactants? If you're measuring a solid and something dropped out of solution, did you not dry it? Do you have another source of contamination? So you need to go back as a scientist, as a critical thinker, and go back and analyze what you did. Maybe you didn't make what you thought you made. So you've got to go back and really dissect what you did in your lab. This doesn't answer where your error is. It just tells you that there is an error. That's all. Okay? 2 problems we demonstrated for you. I've got 2 more that I put up as a PDF file. This should help you. So 1 set of problems just on percent yield, and that you're going to go through, and then the final set of problems that's dealing with stoic, limiting reagent, percent yield, but it's all thrown in together. Okay? Good work, guys. Hope you enjoy.